Beyond the Horizon, Episode 2, Surviving the Void, Living in Space, a dream of science fiction, now inching closer to reality. But can humans truly survive beyond Earth? From deadly radiation to microgravity's toll on the body, space is an unforgiving place. It is a realm of extremes, a cosmic crucible that tests the very limits of our biology. Yet scientists and engineers are finding ways to make interplanetary living possible. The same species that once navigated by the stars, crossed oceans in search of new lands, and split the atom now sets its sights on a new frontier, becoming a multiplanetary species. Today we explore the challenges and solutions of surviving the great cosmic void. Unlike Earth, our oasis in the vast cosmic desert, space offers no breathable air, no protective atmosphere, and no stable climate. Imagine a place where the very air you breathe could kill you, where the sun's rays are both life-giving and lethal, and where temperatures can swing from a scorching 250 degrees Fahrenheit in sunlight to a bone-chilling minus 250 degrees in shadow. Out there, beyond the protective embrace of our atmosphere, lurks deadly cosmic radiation, a constant barrage of high-energy particles capable of shredding DNA and disrupting the delicate machinery of life. It's a cosmic shooting gallery where micrometeoroids, tiny fragments of asteroids and comets, zip around at incredible speeds, each one a potential bullet that could puncture a spacecraft hull with explosive results. And then, of course, there's the ultimate danger, vacuum exposure. In the vacuum of space, there's no air pressure to keep your bodily fluids from boiling. Exposure means certain and rapid death. These are not mere inconveniences. They are existential threats that must be overcome if we are to establish a permanent human presence beyond Earth. How can we protect ourselves from this cosmic onslaught? How can we create havens of life amidst this harsh and unforgiving realm? The answers lie in ingenuity, innovation, and a deep understanding of the challenges we face. We evolved under the constant pull of Earth's gravity, a force so fundamental to our existence that we rarely even notice it. Yet in the microgravity environment of space, our bodies begin to change. Our bones, no longer needed to support our weight, lose density. Our muscles, accustomed to fighting against gravity's pull, atrophy. And our fluids, which normally pool in our lower extremities, redistribute, leading to that puffy-faced look astronauts get, often called moon face. Over time, these adaptations can have serious consequences. Extended time in space can cause vision loss as fluids press on the optic nerve. It can lead to heart shrinkage as the heart, no longer required to pump blood against gravity, grows weaker, and it can suppress the immune system, making astronauts more vulnerable to infections. But humans are nothing if not adaptable. Astronauts on the International Space Station exercise for hours each day using specialized equipment to mimic the effects of gravity. They wear compression garments to help regulate blood flow, and scientists are constantly developing new countermeasures, from artificial gravity systems to medications that can mitigate and indicate the negative effects of long-duration spaceflight. The human body, for all its fragility, is a marvel of adaptation. We are learning how to fine-tune our physiology for life beyond Earth, pushing the boundaries of what we thought possible. Chapter 3, Radiation, the Silent Killer. Here on Earth, we are shielded from the most harmful radiation of space by our planet's magnetic field and thick atmosphere. But in space, astronauts are exposed to a constant barrage of high-energy particles from the sun and from deep space, particles known as cosmic rays. These rays are like microscopic bullets, capable of damaging DNA, increasing the risk of cancer, causing cataracts, and even damaging the central nervous system. Long-term exposure to cosmic radiation is a serious concern for future Mars missions, which could last for years. How can we protect our astronauts on these long-duration voyages? One solution is radiation shielding. Spacecraft can be designed with thicker hulls or with special materials that deflect radiation. Scientists are even investigating the possibility of creating artificial magnetic fields around spacecraft to deflect radiation, much like Earth's magnetic field protects us. Another approach is to develop medications that can help repair radiation damage or boost the body's natural defenses against radiation. And of course, minimizing the time astronauts spend outside the protection of a spacecraft or a planetary base is crucial. Radiation is a silent, invisible threat, but it's a threat we're learning to understand and mitigate. With careful planning and innovative technologies, we can protect future space travelers and allow them to explore the cosmos safely. Chapter 4: The Psychological Battle of Isolation. Space travel isn't just physically demanding, it's psychologically challenging as well. Imagine being confined to a cramped spacecraft, millions of miles from home for months or even years at a time. The isolation, the lack of privacy, the constant stress of living and working in a hazardous environment, these factors can take a heavy toll on even the most well-adjusted individuals. Astronauts often report feelings of loneliness, boredom, and anxiety. They may experience sleep disturbances, mood swings, and difficulty concentrating. In extreme cases, long-duration spaceflight could lead to depression, psychosis, or even suicidal thoughts. So how do we prepare astronauts for the mental challenges of space travel? Psychological screening and training are essential before ever venturing into space. Astronauts undergo rigorous psychological evaluations and participate in simulations designed to test their coping mechanisms. Once in space, maintaining regular contact with family and friends back home is crucial for psychological well-being. Space agencies are also exploring the use of virtual reality and other technologies to provide astronauts with immersive experiences that can help reduce stress and combat feelings of isolation. The human mind, just like the human body, needs support and stimulation to thrive. By addressing the psychological challenges of space travel, we can ensure that our astronauts are not just physically prepared for their missions, but mentally resilient as well. Chapter 5: The Future of Space Habitats. Living in space isn't just about survival. It's about creating environments where humans can thrive. Future space habitats will need to be more than just metal boxes hurtling through the void. They'll need to be self-sustaining ecosystems, capable of providing for all of the needs of their inhabitants. Imagine sprawling space stations with artificial gravity, where you can walk on the ceiling or play zero-gravity sports in vast atriums. Picture greenhouses bathed in sunlight where astronauts can grow fresh food and enjoy the psychological benefits of being surrounded by nature. These habitats will need to recycle everything: water, air, even waste products, turning them into valuable resources. They'll need to be shielded from radiation and micrometeoroids, providing a safe haven from the dangers of space, and they'll need to be designed to foster a sense of community and purpose, combating the psychological challenges of isolation and confinement. We're already seeing glimpses of this future. The International Space Station, for all its limitations, is a testament to international cooperation and human ingenuity. 3D printing technologies are allowing us to imagine constructing habitats from lunar or Martian regolith, the loose unconsolidated material on the surface of these celestial bodies. And advances in closed-loop life support systems are bringing us closer to creating truly self-sufficient environments in space. The challenges are daunting, but the possibilities are limitless. Building a future beyond Earth is not just scientific endeavor. It's a testament to the boundless potential of the human spirit. Epic music swells as we zoom out from Earth, revealing the vastness of space, a sea of stars stretching out in every direction. The dream of living in space is closer than ever, but the challenges are enormous. We must confront the harsh realities of space, protect our bodies and minds from its unforgiving nature, and develop the technologies that will allow us to create self-sustaining habitats beyond Earth. The next episode will take us deeper, exploring the technology and breakthroughs needed to build a space civilization. Are we ready for this leap? The answer, my friends, is up to us. Like and subscribe for the full 20-episode space journey.